Welcome to a new video and episode on my Raspberry Pi 1 connected by band cable to breadboard with electronics and with an analog to digital converter. The Raspberry Pi is running Raspbian Linux and is programmed in Python for this series of experiments. It's also connected serially to a Minicom terminal program, and in the past several episodes I have managed to replace the ADC for a working version, analog to digital conversion, which is necessary for analog sensors like LDR and an NTC and resistors to convert the values to digital, because the GPIO, general purpose input output, on the Raspberry Pi is digital and can't read analog signals. And last thing I did last time was adding this series of potmeters, programmed to be read at the 8th port, which is then port 7, because the first one is 0, and that gave another problem, because it showed that the values are not consistent and I had to press to make nice contact. So that is a bit of a problem, and meanwhile I am connecting another LDR from fischertechnik to the circuit. So the software can run nicely because it's programmed to read from this one and this one. Apart from that, my focus is now on this potmeter, and the question is how to solve the inconsistent or unreliable reading. And when I take it out, which is rather easy, you can see that the pins are quite thick, and that's most likely the reason that it is pushed out of the gates. Simple solution is to solder some pins like this onto it, just modified or whatever part of a staple. So I've been doing that for quite a while with a lot of success, so I probably will do that. In the meantime, first I want to see if things work out nicely, so I start on the connected laptop, which is the desktop on the Raspberry Pi, using VNC, virtual network computing. I start the program, and all values are being read nicely. So let me get one screwdriver, and okay, this leads to nothing because it's too thin. Let me find another one. Is this going better? Yeah, and without pressure, even without pressure, the values are quite strange, because okay, now it gives only the value 1, and slight pressure gives the value 74. No, 47. and now 48, back to 0, then 60. So, and now it's 209, next is 15, so that is not good. And I doubt if that is caused by the unreliable contact, but we'll see when it has those contacts. Okay, now we have the following. I have modified this Potmeter. As I said, I soldered some staples at the pins, and then I have the following. This is a screwdriver, a Phillips. This is an ordinary one, and they both cannot really be used for this, for turning this Potmeter. Then I come to torque, and then with this smallest torque, this is 7, and this one is 7, this one is 8. And now when I put it in, the values are nicely responding. Although it is very big steps, from 60 to 194, pretty large. Now it's 60, 49, 47. Anyway, you can read the resistor value. So my question is when I turn this Potmeter, and it slips a bit, this is really in rather large steps. And when I look at the oscilloscope, I can't really determine which value is which. It's set to 1 second, just like the software. And I'm slowly turning it up. That's a slip. That is a slip because oh, now it's just 32. That is strange. And I actually can't turn it further, so I'm going back. And I'm suddenly at 2. Then at 255. .36, 63. So I don't really know what kind of Potmeter this is, but okay, end of the turn, turning up again. Okay, is this a kind of balance Potmeter, just like I had before with another project? This is 255 and going down quite rapidly, going up again, .55, turning further, hitting the end. Again from left to right, hitting the end, and from right to left, or more appropriately counterclockwise. I can't go any further. Clockwise again. So this is not an ordinary potmeter apparently. So to be honest, I don't know what to think of it, and I should probably look out for a different potmeter. Although the experiment is read analog to digital values, read analog values so it can be converted to the digital Raspberry Pi, and put my finger on the LDR2. That is one. Letting it go. Some better lighting maybe. Alright, covering it up. It is connected correctly, right? Yeah. Alright. So why is this happening? It's like there's no change in value here. Well, that is odd. Okay, let me check this one. Very low value now. 5. Release, and it goes up. Anyway, despite the odd behavior of the potmeter, it goes fine, I think. So, what's next? Good question. So, now for two different potmeters I need two different screwdrivers. And where are we now? Well, I'm using 4 different sensors, although this is, you can hardly call this a sensor, it's just now for testing values, and in the previous segment it was clearly shown that it is a bit odd. However, this one is acting odd as well. The fischertechnik LDR, the ordinary LDR, is acting nicely. This one is kind of static. Now I'm holding it, it says 33 and 35. So it's kind of changing, although, well, how long does it take for it to get a different value, the NTC? And the point is, as it has shown now, that to read values you definitely don't have much on an oscilloscope. It gives all the values, and apart from the clock, this is the probe for all the values. The data out, data in is not really in use. Well, at least not in this case. And well, this is C bar, the which gives, yeah, what does it give anyway? This is not the clock signal. It's a device selection, device selector. But I have only one device, and that was my problem. Whenever I started, I thought that everything was one channel, and it turns out in software that it is just one device with multiple channels, and it is instantiating for each device. So this has an instance of a device, and so it goes for this one and this one and this one. And it's all one device. So in order to read it, you need a screen. How to go on? Well, ADC is nice. Reading is nice. How to explain that this doesn't work anymore? Well, it does work, although not as fiercely, because these two are have for some reason the inverse readings. Now this one is high and this one is low. So if I cover up this one, I expect it to go high, and it did in the past. But now it just stays 1. Now it's 2, back to 1. So it makes no sense. And when I replug it, doesn't make a difference. And then I found out why. Wait a second. If I put this in more firmly, what happens then? This is hardly making any contact, this one. And neither is it now. So this is not very good. Now the potmeter, this potmeter is not the best connection at all. So that's the problem. And I think that sums it up for now. What can be done next? Nice question. Okay, this series of videos have been about using an analog to digital converter with the Raspberry Pi. That has been successful. New experience for me, how to use it, which voltage it works with, a protocol, SPI, using it, finding analog sensors to use different pins, and programming it in Python. So what's up next? Well, I don't know yet, but I might continue with this in combination with other chips, like for example I2C or whatever. Those can be used with Raspberry Pi as well, and I'm very curious if I can combine them. So for now, this series of videos on only Raspberry Pi and a breadboard with an analog digital converter has come to an end, but who knows what comes next. I started this for line sensors, and that grew into more than one sensor. I'm happy with that. So for now, anyway, thank you for watching. If you like this video, please subscribe to my channel. Give it a thumbs up, leave a comment, very much appreciated, I always answer. You can also follow me on Twitter, retweet and like, leave a comment. You can also follow me on Instagram, like and leave a comment. Please donate to keep videos coming to you. More information on my website, and you can also become a patron and have your name mentioned on my website anyway, but also with my videos, depending on the pledge you make. For more information, also see my website and my Patreon page, of course. And this may be continued. Once again, thanks for watching, and bye bye.